Problem 25. A semicircle is inscribed in an isosceles triangle with base 16 and height 15 so that the diameter of the semicircle is contained in the base of the triangle as shown below. What is the radius of the semicircle? The idea here is not to get deceived by initial impressions. Look at this very annoying small gap. That's going to be very difficult to solve for. So let's try to remake this into a much nicer looking shape. If this were to be the center, then I can connect this to be the radius, and I connect this to be the radius. What do you notice about these radii? Well, it's inscribed, so therefore this must be tangent. Therefore, this is a right angle. Right angles are very special because guess what? Pythagorean theorem. And that's my suspicion, but let's connect all the points. The idea here is when you have points, typically connect them in geometric questions because when you have points, you get lines. When you have lines, you create shapes. When you create shapes, you create relationships among the sides that can help you solve the answer. So with this understanding, what can we say about this length right here? We don't know it. We only know that the base is 16, but this is an isosceles triangle, so this is 8 and this is 8 because this is a perpendicular bisector, because that's perpendicular. Now that's 18, the height is 15. If the height is 15, then what is hypotenuse? Well, the hypotenuse, I'll call that h, will be equal to the square root of 15 squared plus 8 squared. If you know your Pythagorean triples, that's equal to 17. But let's verify. That's 225 plus 64. That is equal to 289. We know 17 times 17 is equal to 289. Therefore, this is equal to 17. So if this is 17, then we basically solved the question. Why? Because this is the radius. What can we say about this triangle? Well, how many ways are there to solve the area of this triangle? This is base, this is height. Well, one way is to do BH divided by 2. Another way is to draw this altitude, call it H1, call this base 2. We can also do it as H1 times base 2 divided by 2. Both of them gets the area of the triangle. And in this case, we are going to go for the latter. We're going to go for H1 times B2 divided by 2 to get the area, because this includes R. Notice, these two expressions are equal to each other, and we're going to exploit this relationship. How? Base times height divided by 2. Well, in this case, that's 8 times 15 divided by 2. And that must be equal to the radius R times H. Well, the H is 17 divided by 2. Because remember, just finding the area of the triangle, there's three ways, right? There's this base times this height. There's also this height times this base, and they give the same triangle's area, so we have this expression. Therefore, we have basically solved the question. R is equal to 8 times 15 divided by 17. 17 is prime, so we must simply figure this out, which is equal to 120 over 17. What we're trying to find? We're trying to find the radius, so 120 over 17 would be our answer, and that would be choice B, concluding the 2016 AMC B series.